Okay, so let's get started then. All right, yeah. Welcome everyone, and thanks for being here and I've lost count. I think either the 8th or 9th in our series of lectures on evidence, models, and explanation. And today we have with us Professor Michael Strevens from New York University. And Professor Strevens works on a variety of topics related to the philosophy of science, explanation, confirmation, probability. In fact, the first time I encountered his work was when I was in graduate school, on a really lovely book on probability that he wrote. And he has a new book that has just come out that is, I believe, for a more popular audience. So once this talk is over, please rush to buy that at your nearest bookstore. Today he's going to be talking about the logic of science, and I believe offering a partial defense of Hempel's account of confirmation. So without further ado, please go ahead, Professor Strevens. Yeah.
Well, thanks very much. It's really great to be talking to you all. Let me just get everything up and running. Okay, so in fact, this talk is in some ways the prehistory of this new popular book, new general audience book, which has come out this week, called The Knowledge Machine. And your invitation to talk about evidence really came at the perfect time, because this is a book that was a response, if you like, or a kind of working out of some ideas, which first came to me from thinking about the not very general audience topic of confirmation theory. So as you will anticipate, this talk is largely about confirmation theory and exactly, I suppose you could say, what its subject matter is and exactly what role it plays in science. Something you may have thought was settled, but which I'm aiming to unsettle. So it's great to be able to actually go back to these ideas and present them in a more philosophical context. In effect, to get back to a project that I was diverted from what I felt was the need to write something much more general about science, something that is really not technical at all, but which, as I say, was a response to problems raised by thinking about really exactly what Hempel was up to when, what is it now? I guess it's 75 years ago. I guess it's 75 years ago. Wow, that his famous paper on the logic of confirmation was published. Okay, so our subject matter is evidential support, and I probably don't have to dwell very long on these ideas that you're also familiar with. That the question is one of how evidence bears on the theories we have. These kinds of questions about support are the questions that motivate philosophers to do what they somewhat misleadingly call confirmation theory. I suppose many of you have probably taught this, and you know the first thing you have to do is explain to people what this mysterious term confirmation theory really means. Not quite what you think. Anyway, confirmation theory, of course, is the study of, or at least it appears to be the study of what level or direction of support any particular piece of observable evidence gives to any particular theory. So you find in the philosophy of science literature two approaches to doing confirmation theory. One you might call the anthropological approach, which looks in the first instance to what scientists are actually doing, looks at their publications and sees, examines and systematizes the way that scientists talk about evidential support. And one philosopher who follows the anthropological approach largely is Hempel himself. Of course, we think of him in some ways as a very logical philosopher, and he is, and his systematizations are in part rationalizations, but his immediate impetus is to capture what he sees happening, I think, in the pages of scientific journals, just in the same way that in his work on explanation, he was, in the first instance, not exploring the consequences of prevailing philosophical theses about explanation, which generally held that explanation was a deep dive into the metaphysical structure of the universe, and therefore, in empiricist times, something to be shunned by science, perhaps something that was simply impossible to do. Hempel said, well, scientists nevertheless seem to think that they're explaining things. Let's just look at what they do when they say they have an explanation. Likewise, I think with confirmation, Hempel did much the same thing, and that's going to be an important point to remember going forward as I talk a little bit about what Hempel actually produced. The alternative approach is the question is, what ought they to be doing? How does evidential or inductive reasoning in general really work? What's the right logic for this sort of thinking? Many Bayesian philosophers of science take an approach like this. Now, you don't have to take this approach to be a Bayesian. In fact, I think of myself as a Bayesian sympathizer in some ways who doesn't take this approach, but the kind of Bayesian who wants to start out by giving as something that's as close as possible to an a priori proof of the basic principles of Bayesianism. For example, the Dutch book, Arguments for Conditionalization, is engaging in this kind of project. The point is to establish that Bayesianism is the one and only proper form for inductive reasoning. And so scientists, if they're not using it already, had better start soon. Okay, so I talk about the logical approach by way of contrasting it with this anthropological approach, which I'm attributing to Hempel. Again, I'll say Hempel, of course, is logical in the sense that he presents his confirmation theory in a very logically rigorous way. And in fact, he holds himself to some very high logical standards. But nevertheless, I think that his basic thought is what logic or what formal system captures what scientists say about evidential support in their publications. So let's get on to Hempel himself. I am sure many of you are familiar with Hempel's writing about this, but I'll assume that some of you at least need a little bit of a refresher. It's not going to matter very much exactly. The details don't matter too much. It's more that some broader features of the story that matter, but still it makes sense to talk a little bit about the details just to, as well, if nothing else, to jog your memories a little. So Hempel has what is generally called an instantialist theory of confirmation, in which confirmation is driven by the idea that a hypothesis is confirmed by its instances or disconfirmed by its counter instances. I'm just going to focus on the kind of case that Hempel starts out with, the simple hypotheses of the form all F's to G. That will be enough to introduce the basic story. So in Hempel's story, a piece of evidence directly confirms, and there's going to be indirect confirmation too, directly confirms a hypothesis of this form, of the form all F's to G, just in case either it's an F that is also a G. So if all F's to G is all ravens are black, to use Hempel's famous example, then a raven that is black is a direct confirmer. But also, as I'm sure all of you will recall, a non-F, a non-raven will also be a direct confirmer. So a yellow banana, for example, is also a direct confirmer, an odd feature of Hempel's theory that I won't in fact dwell on today. A disconfirmer, well, is going to be an F that is not a G, so a non-black raven. Okay, that's direct confirmation, but there's also indirect confirmation. And a piece of evidence is an indirect confirmer if it directly confirms some other hypothesis that entails the hypothesis in question. So confirmation flows from hypotheses to their logical consequences. That direct confirmation is going to move through a hypothesis into what it entails. To continue with the example of ravens. Suppose you see a raven in the mountains of New Hampshire. This is really just an excuse to show you my holiday snapshots. And it is indeed black. Then what you have here is a direct confirmer for all ravens are black, and an indirect confirmer for a hypothesis such as all Australian ravens are black. Okay, well, because this raven you've seen is not an Australian raven, it's not an instance of the Australian raven hypothesis, but because it's a consequence of the more general raven hypothesis, it gets confirmed by the raven nevertheless. Okay, and that's the lecturette on Hempel done. So again, I hope that's refreshed your memory of the basic features of Hempel's story. Now here are some features of the theory. One feature which is not brought out by my refresher, but Hempel rightly thought was incredibly important, is that it gives a criterion. I know I haven't talked about it at this level of generality, but it gives a criterion for direct confirmation for any hypothesis, no matter what its logical form. So not just the all F's are G kind of logical form, but absolutely anything you could formulate in predicate logic. It also solved a problem that was raised by an earlier version of the same idea that Hempel attributes to the French philosopher of science, Jean Nicot. So it solves this contradiction that Hempel has found in Nicot's criterion. And that's another thing I won't say any more about. So these are some good features of the theory. The theory also has some limitations, which Hempel was well aware of and acknowledged that needed to be addressed. So this was the qualitative theory that was published in that 1945 paper was going to be enhanced by later work. That was the plan. One limitation is that the theory is purely qualitative in the sense that it doesn't quantify the degree of support that a confirmer gives to a hypothesis, or the degree of undermining of negative support that a disconfirmer gives to a hypothesis. It just tells you when a piece of evidence confirms a hypothesis without saying by how much. The other limitation, which is certainly arguably an even more serious one, is it only allows hypotheses about observable matters to be confirmed. So if you think about just the all F's or G's case, your evidence, or as Hempel lays it out in more linguistic terms, your evidence statement, your observation statement has to be couched in terms of the properties that actually appear in the hypothesis. So if your observation statements are only about observable properties, you can only confirm or disconfirm hypotheses about the observable. Maybe this seemed like less of a fatal flaw back in the days when it was thought that all scientific hypotheses could be in some sense reduced to claims about the observable. But of course, even Hempel himself was not very confident about that. So this was another issue that needed to be addressed. Okay, those are my two limitations. Now on to some oddities of Hempel's theory. Okay, the first one I've already mentioned, the raven's paradox, that the yellow banana is going to confirm all ravens are black. As I said, I'm not going to talk about this anymore, but I could hardly have a slide about oddities without mentioning the odd probative role of the banana. Okay, now on to a couple of oddities that are more germane to the talk today. One is that Hempel's story ignores what are sometimes called the superempirical virtues. So what I mean here are virtues like the simplicity of a hypothesis, or zeroing in more on properties that concern the relation of the hypothesis to the evidence in question, the simplicity of the way that the hypothesis explains the evidence, or the beauty of the explanation, or perhaps the unity, the unified way in which a hypothesis manages to explain or predict a whole range of pieces of data. These are things that have traditionally been thought to enhance the evidential support that the evidence is giving a hypothesis, yet they're completely left out of Hempel's story. Likewise, the epistemic context is left out. So other background knowledge we have that may be relevant to what's going on is not given any role in the story. Take the case of the Australian raven, for example. Now, it may be that you know that although swans in Europe are white, that Australian swans are actually black. So you know that in the matter of bird color, Australasia can be a bit of an outlier. Surely that's going to bear on your inclinations to take the observation of Northern Hemisphere raven, to consider the color of that Northern Hemisphere raven to bear on the color of ravens down in the chromatically contrarian Southern Hemisphere. The philosopher I.J. Good uses this feature of Hempel's account, or this oddity, or perhaps simply limitation of Hempel's theory, to construct a kind of a rather artificial example, but still quite telling, in which observing a black raven actually disconfirms all ravens are black. Simply because I don't have the time, and to keep things from becoming too elaborate, I won't talk too much more about those issues, but this aspect of Hempel's account will remain on the table and important for what I go on to say. Okay, so those are the three oddities I'm going to mention. And of the oddities and the limitations, I'm going to choose three in particular to focus on. The fact that Hempel's confirmation is purely qualitative, that it ignores the superempirical virtues, and that it ignores epistemic context. Okay. Now, finally, here comes my thesis. Okay. These all look like problems. We know that epistemic context is important. It's obviously important. Surely certainly the majority of philosophers of science think that the superempirical virtues are important, and many scientists do too. And any kind of logic of inductive support has to quantify the degree of that support. So these all look like real difficulties. Nevertheless, I want to propose there's a sense in which what Hempel has captured here is the way confirmation actually works in science. Okay, so confirmation in science, or at least something, maybe I shouldn't use the word confirmation anymore, but the thing that Hempel was looking at that is kind of playing the role of the evidential support relation, if anything is, in scientific literature, actually has these features of ignoring the superempirical virtues, epistemic context, and being qualitative, or as you'll see, even something a little stronger than that, not quantitative at all. Okay, so that's what I want to convince you of, and I hope you think that this is very implausible, because I think that if you grasp what I'm saying here, then at first blush it is very implausible. Okay, so you should be thinking, well, that can't possibly be right. Okay, and then I'm going to explain to you the sense in which I think it is right, and you'll say, okay, well, now I see this claim as a little bit, perhaps not quite what I took it to be, but still, I hope you'll think it's rather interesting. Okay, my own, this is the way I got started on thinking about those ideas was simply teaching Hempel, actually, in undergraduate philosophy of science classes, and looking at some of these gaps in Hempel's theory, and wondering exactly what he was trying to get at, and then beginning to see that there was a sense in which he had simply looked at the scientific literature and, as it were, transcribed the structure of the evidence theory relation that he was seeing in the literature, almost in spite of himself, because I think he himself found what he wrote down to be a little puzzling. Okay, the thing I have to say next is crucial to making this thesis, to having this thesis make any sense whatsoever, and it's a distinction which I think is very important, which in a sense you all know about, but which I think is really critical to thinking about the nature of confirmation theory, or the nature of the way we should organize our inquiry into evidential support as philosophers of science. And this is a distinction between what I call official scientific argument and private scientific reasoning. I think those are pretty, those terms pretty much lay out the distinction I have in mind, but let me say a little bit more to make sure that it's clear. So there are a whole lot of different places where we see scientific deliberation in some sense happening. Here are a few of them. So places where, as I put it here, evidence is brought to bear on theory. Scientific journals, of course, and in some disciplines, conference papers are just as important as journals. A completely different kind of venue, the scientist's own mind, as they think through the implications of evidence for various theories they're interested in. So one of these is a very public and official, or the journals and the conference papers are very public and very official. The mind is, of course, very private and not even subject to strictures of officialdom. And then in between, you have these more informal places. On the one hand, the lab meeting, which is fairly private, where scientists are talking about what's going on with their research. And then venues like popular books or television or podcast interviews, which are very public, but also informal and not official. And as we all know, scientists there feel free to say things, often in far less careful ways than they do in their official publications. Which is, if it stirs up public interest and opens the funding floodgates, is fine with me. Anyway, the point is simply that there are many of these venues. So some of these venues, as I've said, are more official. And in fact, these are the venues I have in mind when I talk about official scientific argument. And official here means not just formal, not just set in type, but the idea here is that something like a scientific journal is conceived of as a repository of argument and fact, as the repository of argument and fact for a scientific domain. This is where we put things if we really want to save them and communicate them to scientists who are coming along later on. And furthermore, these are just in general the official channels of scientific communication. Of course, there are also the official places to register your achievements so that you get credit for those achievements. That's a little bit less important in my story. Maybe the most important thing is this idea that here, these are the official channels of communication. This is how, not the only way that scientists speak to one another, but the way they speak to one another that is intended to last forever. Okay. On the other side is everything else, both a relatively private venue like the scientist's mind and also a relatively public venue, very public venue like a popular book. These, I put them all under the heading of unofficial. Okay. But just for simplicity's sake, let me take as the paradigm here, private scientific reasoning, what's going on in a scientist's own mind. Okay, so just contrast these two places, scientist's mind and the official channels, the journals and conference papers. Okay, maybe you can anticipate what I'm up to now. Here is a claim I want to make, which of course is going to dovetail in a very significant way with the thesis I want to advance, that these two venues have very different evidential support structures. That is, if you look at the formal relations that are established between theory and evidence in the mind, you'll find something that looks very different than if you, as Hempel did, look at the formal relations in the journals. How so? Well, let's start with private reasoning. The relations of evidential support you find in private reasoning are, well, pretty much exactly what a confirmation theorist would expect, relations that do quantify degree of evidential support. So when a scientist is thinking to themselves, they're not just saying, does this piece of evidence support the hypothesis? They're asking by how much? And they do take into account the superempirical virtues. Is this an especially lovely or elegant explanation of the evidence I've accumulated? And they do take into account all aspects of epistemic context, of background knowledge. So the fact that one part of the world tends to be more biologically unusual, perhaps. That's a bit of a toy example, of course, but in the matters of bird color will be taken into account. In other words, what you get in private scientific reasoning is everything a Bayesian might want, the full suite of the full complexity and richness of inductive logic, as we philosophers tend to, at least these days, tend to imagine it. Okay. In official scientific argument, by contrast, what you see is something rather different, and as you'll anticipate, more Hempelian. We do find a certain evidential support structure, but it doesn't quantify degree of evidential support. It ignores the superempirical virtues. It ignores many aspects, maybe not all aspects, or at least it doesn't ignore them completely, but in ways that you would think are very important and that are very important in private reasoning. It ignores many aspects of epistemic context as well. So now you can see how I'm qualifying my thesis. This is a thesis about official scientific argument, not about private reasoning. The thesis does not say that quantitative inductive reasoning has no place in science. It does, but it's in the scientist's mind and not in the journals. Okay, so now on to say a little bit about this thesis. My strategy here is, in effect, to point out to you that you already believe the thesis. So once we make this distinction between the official scientific argument and private reasoning, and we allow ourselves to contemplate the possibility that there's a different structure of evidential support in one than in the other. So we don't, in other words, we don't smush them together and assume that we're talking about a single thing as we look from one to the other. Then the things I've said about the way that evidential support works in the journal papers are things that you already know about scientific writing. Okay, so that's the strategy. Now I'll get on with it, and I'll be much briefer than I ought to be, but I hope that that you'll see what I'm getting at, and you'll realize that what I'm saying is surprisingly plausible. What I'm saying will not establish my case in any sense, but I hope you'll begin to see that it's not a crazy thing to say. Okay, so I'm going to focus. Here are the three things that that I claim characterize the evidential support structure and official argument. And I'm just going to focus on the first two. The question of epistemic context is a terrifically interesting one. I think what often happens, so I'm going to ignore it, as I say here, but I'll say one thing about it before I go on to ignore it. Often a scientific paper does provide various important aspects of context. It will mention contextually important facts. It will comment on things like the conditions under which certain measurements were made or experiments conducted, but it won't make any systematic attempt to bring that context to bear on the evidential support relation. That is, it will, as it were, give you the information, give you the context, give you the background that you need privately to conduct your inductive thinking, but it won't, the paper itself will in no way involve the context in the evidential support structure. All right, I'll carry through on my promise not to say more about that. So I'll just talk a little bit about not quantifying the degree of evidential support, and then a bit about ignoring the superempirical virtues. Okay, first of all, not quantifying evidential support. Now, as I say, I think we all already know that scientific papers do not quantify evidential support. We know they do quantify some things. For example, a lot of scientific writing hinges on some form or other of null hypothesis testing, which calculates a thing called a p-value, the probability that the null hypothesis ascribes to what was actually observed. Often enough, a paper might also calculate the probability that the theory we're actually interested in, not the null hypothesis, but the one that's being tested, a paper will explore the way in which that theory or hypothesis predicts or explains the things that were being observed. So, well, say, show that, say, calculate using say, Einstein's general theory of relativity will calculate a certain angle by which light is bent when it passes close to this degree of redshift or something like that. Okay, that stuff definitely, and this can be in cases where probabilities are involved, where you have a stochastic theory. These will be numbers. These are quantifications. There's definitely calculation going on. But the calculation is all of what the evidence, as it were, says about, what the theory says about the evidence. The probability the theory is ascribing to the evidence, not the probability that the evidence is ascribing to the theory. In fact, if you look at the various formal structures that are used in scientific papers, there's not even a test for determining the direction of evidential support. So in null hypothesis testing, we're told and we may reject the null hypothesis, and there's a kind of a supposition lurking in the background. That means we have some sort of confirmation for the real hypothesis, the competitor to the null hypothesis. But even this is not asserted. Okay, so this is, and of course, these features of null hypothesis testing are, every so often scientists look at what's going on and they think, wait, are we crazy? Why are we doing this? And right now we're in a period where that's going on for various reasons. Some of it is to do with the replication crisis, but some of it is in as people call it, but some of it is also just coming from statisticians, philosophers of statistics, scientists who are having a bit of a methodological meta moment and thinking, yeah, how does any of this stuff make sense? What are we even doing here in our papers? Why is calculating a what is calculating a p-value actually telling us about the significance of the evidence for the theory? And the answer is it's left unspecified by the rules that scientists follow very closely in constructing their papers. So what you do get in a scientific paper is, of course, a description of the evidence, and often a very careful description of the evidence and the way it is produced. Typically, some sort of connection of the sort I've been talking about that goes from the theory to the evidence, the way that the theory predicts the evidence or the null hypothesis, fails to predict or ascribes a very low probability to the evidence. So that explanatory or predictive connection between theory and evidence is all laid out nicely and often in great detail. And then when you're dealing with something like relativity theory with rather complex and impressive mathematical calculations. But what's not in there is the impact of evidence on theory. That's entirely left to each scientist to, as it were, figure out for themselves. Of course, scientists who read these papers are thinking, what is this evidence telling me about the various theories? In their heads, evidential support is being quantified, the context is being taken into account. Do I know this? Do I trust this person's experimental abilities, for example, or are they well known to be a sloppy experimenter? But none of that is being done on paper. Okay, so as I say, I think you all already know this. What I'm doing here is giving you a new perspective on what you know. What you're seeing is not some sort of strange, imperfect registration on paper of the official logic of evidential support or confirmation in science. It's rather that the official structure simply declines to calculate degree of support. It's something that it simply does not do. Okay. onto the superempirical virtues. And here I'm just going to talk about one superempirical virtue, everyone's favorite, I suppose, beauty. Okay. So when people say that beauty is a superempirical virtue, they mean something along these lines here, that a theory is beautiful, or that it's perhaps, I think more pertinently perhaps, that a theory's explanation of the evidence is beautiful, is something that counts in its favor. Evidentially counts in its favor, of course. It's not just nice to contemplate, it actually is more reason to believe in it, okay? It's more likely to be true than had it been plain, let alone ugly. So you don't need to look very far to find scientists lauding the power of beauty as something that's or maybe evidentially important is not quite the right word, hence the term superempirically, but it's something that's important. As I said, these are superempirical virtues, but they're often attached to the way that a theory explains the evidence. So they're very much connected with the way that evidence bears on theory. So if we just even restrict ourselves to Nobel Prize winners in physics, we still have many, many quotes to choose from. And here are a few. So all of these are saying, well, maybe Dirac's is not explicit, but but it's quite clear that he's thinking much the same thing as Gell-Mann and Weinberg, that beauty counts in a theory's favor. It gives you more reason to believe the theory than otherwise. So if your beautiful theory is not quite fitting the evidence, Dirac thinks, stick with the theory and things will come right in the end. Beauty is that powerful of a reliable of a guide to truth. Of course, we shouldn't restrict ourselves to what physicists say on the side. I mean, probably all of these writers are getting a little bit carried away. But here is a somewhat more careful statement that still very much brings out the importance of as Brian Greene here in his book, The Elegant Universe puts it, the aesthetic sense. Okay, that he's talking about physicists in particular, are using, well, I'll just say, are using beauty as a guide to truth. Okay. He goes on when he's in a couple of pages when he's talking about this, though, to say something that all of those physicists will all equally well acknowledge, that scientists will all equally well acknowledge, and often they, in the very same breath, that theories are not judged by their aesthetics. The fact that a theory provides a beautiful explanation of a piece of evidence is considered irrelevant in these judgments. What matters is, as he puts it here, the hard experimental facts. And of course, what he's talking about is simply the fact whether the theory actually manages to predict the evidence in question. So the beauty of the explanation doesn't matter. What matters is that there is an explanation, and an explanation just in the rather shallow, actually Hempelian sense, that we can deduce the evidence from the theory and the appropriate initial conditions. Okay, and I think we should understand this claim in a rather strong way. It's and I say this is because, and actually looking at the papers these very physicists write, you can see this at work. Beauty is not offered, and in fact cannot be offered as a consideration in favor of a theory. So it's not actually permitted in a scientific paper to say, you should believe my theory because it's beautiful. Okay, you may hope that your readers in the privacy of their own minds will be thinking, oh, that's just lovely, and they will resonate to the gorgeousness of your explanation and believe it more as a consequence. But the official rules of scientific argument, that is the official rules for how to marshal evidence in support of your theory in scientific writing, say you must not appeal to beauty, or indeed to any of the other superempirical virtues. Again, I think this is something that scientists are well aware of. I mean, they have to be aware of it because they're writing papers according to these specifications. And I think we philosophers of science are pretty well aware of it too. Nevertheless, there's something about this which is so, if you put aside the feeling of familiarity that you have with these facts, with the two sides of what Brian Greene says, for example, there's something about it which is strikingly weird and in fact even irrational. I've used this irrationality both in the title of my general audience book and also the title of this talk to get people's attention. Science seems to be saying on the one hand, or scientists seem to be saying on the one hand, paying attention to beauty is really helpful for figuring out what the truth is. But on the other hand, an official scientific argument, we must pay no attention to beauty. Beauty. Duty is to pay no attention to beauty. Okay, so beauty is terribly important, and also we must ignore it. So official scientific argument is ignoring something that is generally acknowledged to be, as I put it here, a powerful and a readily available source of information. It's not very expensive to assess a theory's beauty. In fact, these judgments seem to come pretty much unbidden to physicists, in particular when they do their theorizing. So if this is true, if official scientific argument is ignoring information that is potent and readily available, then it's violating what we philosophers call the principle of total evidence, which says you should consider every available source of information, as long as it's not not practically infeasible, which it certainly isn't in this case, because as I say, physicists have as it were, these judgments about beauty at their fingertips or at their eye tips or whatever organ it is that we use to assess beauty. Okay, so official scientific argument is violating the principle of total evidence. And of course, let me also say this is in effect the argument that I.J. Good was making against Hempel, if you recall what I was saying many slides ago, when Good was pointing out that Hempel's instantialist theory ignored context, that in effect Hempel's theory of confirmation is violating the principle of total evidence. It's not taking into account the background information, and so it's not always going to get the right answer about whether a piece of evidence supports a theory. Anyway, so what's coming up next? Oh yeah, so at this point, you may be asking yourself, well, maybe this, what I'm calling public scientific argument, is not really a thing, or, well, it's a thing, it's out there, but it's not a thing that's worthy of philosophers' attention. It's a kind of, as it were, a sociological excrescence. It's a byproduct of good science, but not something that in itself is critical to good science. I mean, everyone has expected from the rules of scientific argument is some sort of inductive logic, right? That in some sense conforms to all of the canons of good inductive reasoning, which involves quantification, taking into account background information, and so on and so forth. What we're getting, if I'm right, is not really a logic at all, because the rules here are not quantifying, not only not quantifying evidential support, but not even, certainly much of the time, according to many of the templates for writing a scientific paper, not even, strictly speaking, establishing the direction of evidential support, whether you have a confirmer or an underminer. And in fact, it's not just not a logic, but it seems outright illogical insofar as the rules are violating the principle of total evidence. So what might be going on here is Hempel has set out in good faith and without expecting any trouble to transcribe these rules of scientific argument, the structure that evidence bears to theory in a well-written, properly written scientific paper. He's written down, he's captured something about the structure, but the structure is this non-logical, in fact, illogical mess. And so what we get is a theory of confirmation that has all of these shortcomings. And the right response to this might not be to try to fix it up, but just abandon the project altogether. Just move on. Forget about official scientific argument as a topic and work on the logic of private reasoning. Nevertheless, I think the rules of scientific argument do seem to be doing something. They're not a mess in the sense that they're unsystematic. They spell out a certain notion, or they give rather fine-grained rules for what counts as empirical evidence, what's an appropriate thing to publish. The rules, for example, for when evidence counts as statistically significant. And they also spell out and quite rigidly enforce the idea that official argument should be conducted by exhibiting evidence of this sort. So something seems to be going on here. And therefore, it seems that we shouldn't prematurely close down the investigation. There are still interesting questions to ask. What are the criteria? What are the criteria for something's counting as a piece of empirical evidence? How can a general story is what I'm looking at here that encompasses both the sort of notion of statistical significance and p-value testing and all of the other things that the different kinds of rules that scientists use in different areas for when they're putting together a paper. What are the procedures for exhibiting that evidence? Exactly what do you say or what don't you say when writing that paper? And finally, and this is the topic I'm going to more or less finish with, why do these rules exist? After all, the rules don't look like they're anything like the thing that we're expecting. They don't look that it doesn't look like the rules exist in order to provide to replicate in public the workings of our private inductive logic. So what are they doing? So I want to talk a little bit about the function question. This is what I get into in my book, The Knowledge Machine. So this is really more just a little bit of a preview of what happens in that book. I feel that question needs to be answered in order for us to take seriously this project of looking at the rules of scientific argument at all. So I'll say just a little bit about this. Since I've written a whole book about it, you'll know that there's much more that I have to say. So when I first started working on this, and I was thinking and starting to see the parallels between what Hempel produced and what you actually find in the scientific literature, I wondered if some sort of explanation from objectivity accounts for the rules, the argument rules having the form they do. I ended up instead going for an explanation from motivation, and that's what this new book is about. But let me say a little bit about the objectivity story, just a little bit to give you my reasons for abandoning it. So the thought I had was, well, maybe these rules of scientific argument exist to take all of inductive reasoning, but then to rip out the parts that are too subjective and only leave the parts that are really quite objective. So on the one hand, predictive success is objective. On the other hand, beauty is rather subjective. So maybe what we do is we leave beauty out because it's too subjective. We know it will still have a place in scientists' private reasoning, but what we want in our official records is just the objective connections of evidential support. If we take, though, this demand for objectivity seriously, then we have to acknowledge again something I think is now the conventional wisdom, and rightly so, that predictive success is not really objective either. Entailment is objective, but what entails the evidence is always a theory plus many auxiliary assumptions, and we know that the real the import of evidence, in so much as it hinges on predictive success, is going to depend on the credibility of these auxiliary assumptions. We have many, many examples from the history of science of cases where scientists disagree in ways that are very subjective about the credibility of auxiliary assumptions. One example I use in my book is the case of Eddington's measurement of the bending of light during the solar eclipse to test Einstein's theory of relativity. And Eddington has several different setups, and one of the setups gives measurements that are closer to what Newton's theory would predict on his understanding than what Einstein's theory would predict. he thinks something has gone wrong with that setup, and presumably we can now say he was right. But really, his reasons for thinking that are pretty subjective, and other scientists at the time thought that they were rather subjective. And so this so-called predictive success is something that actually hinges on your accepting a certain interpretation of what went on with the measurement instruments, and that interpretation is not so objective after all. Also, just purely formally using something like the Bayesian systematization of inductive reasoning, you can show that depending on your degrees of belief, the very same piece of evidence can either support or undermine a given hypothesis. So we can see this all working its way out on the formal side. So I think if we really were to remove everything subjective from the logic of evidential support, you would get something that's not even a qualitative theory of evidential support. This quest for objectivity would be self-defeating. Now, maybe you could tell a story where science has set out to create the objective logic of evidential support, and without realizing it, has ended up with something that's not a logic at all. So this in a way, this turns into, the objectivity story turns into the mess story, that scientific argument is a result of making one bad decision and pursuing it to its ultimate self-defeating endpoint, a thing that doesn't make sense as a structure for evidential support at all. But I prefer to have a story that does give a positive role for these rules, and that's the motivation story. I see well, I think actually I'm pretty close to the end of the talk, so timing should be okay here. Okay, but I won't delay too long. So I'm pretty sure you're all familiar with Kuhn's version of the motivation story, Thomas Kuhn's version in his book, The Structure of Scientific Revolutions. Kuhn, of course, thinks that research, scientific research is always governed by a paradigm, a kind of a recipe, rather specific recipe for doing scientific research. And he famously thinks, sometimes he has stronger versions of this and sometimes less strong, but I think his story is particularly interesting in the stronger version, actually. Sometimes think that scientists can't even imagine the paradigm failing. So they have this recipe for doing science that they think is guaranteed to succeed at what he characterizes as solving all the puzzles of the domain in question. And he says that with this assurance that the paradigm cannot fail, scientists are feel enabled to, or feel motivated to, or blindly charge in without considering the risks, and focus on, as I put it here, tiny little details in the observable structure of the universe that can be, often are, incredibly expensive, incredibly time-consuming to unveil or produce. But it's these tiny little details, like the very small differences, say, in Eddington's photographic plates when he was testing the bending of light, that actually move science along. They're the details that show that Newton's theory, for example, or for that matter, Ptolemy's theory, although very, very good, is not very, very, very good. And that's what enables us to move on to something that is observationally almost says exactly the same things, but gives a completely different picture of how the universe really works. So for Kuhn, the peculiar institutions of science, in his case, the paradigm-governed nature of science, this is my favorite quote from Kuhn, forces scientists to investigate some part of nature in a detail and depth that would otherwise be unimaginable. And, as he goes on to say, that's necessary for progress. Now, I think that however much Kuhn has inspired modern day philosophy, history, and sociology of science, most of us no longer think that this very strong conception of the paradigm is viable. So the story can't be right. at the level of detail at which Kuhn tells it. And I won't say any more about that. But maybe, nevertheless, that's what I have on the slide here so far is right. There is a peculiar institution of science that has this function of motivating scientists to become detail-oriented in a way that ordinary people just would never be detail-oriented. So there's a kind of motivational institution in science that is responsible for uncovering precisely these tiny observational discrepancies that have driven scientific progress. Well, what would these peculiar institutions be if not paradigms? They would be the rules of official scientific argument. Okay, these rules, as I've already said, force scientists to make their case using only empirical evidence. So in particular, considerations from beauty and all the superempirical virtues are ruled out of court when you're writing a scientific paper, along with other considerations, religious arguments. I mean, now it's hard to remember a time when that would have seemed to be a way that you would make progress in scientific reasoning. But of course, right in the middle of the scientific revolution, it was tremendously important for many thinkers, philosophical arguments and so on. Just the evidence, just the empirical evidence as defined by the rules of scientific argument. So you can see scientists, if you like, not as in the grip of a paradigm whose mental vice they can't escape, but rather, I think it would be better to see them as joining a kind of a game, the science game. And in the science game, you have to play by the rules. You have to play by the rules of scientific argument. And that means that you're going to be always and only supporting your theories by pointing to some kind of empirical evidence. And this is what means that researchers dig up this detail, the details that give scientists the power, give science its power to find out what's wrong with a theory that seems, like it's pretty satisfactory in many ways. Okay, so this is not, I don't intend any of this. This can't be convincing you. It's just well, I'm happy for you to be convinced, but I just want to give you a flavor of the story that I tell in my book. So what I'm thinking is the rules of scientific argument, although they don't look like what we expected, they don't look like an inductive logic, they look weird in many ways, especially this sort of illogical violation of the principle of total evidence and the seeming complete lack of concern for quantifying evidential support. That's okay, that doesn't matter, because what the rules are really for is channeling all of this scientific energy into the production of more and more detailed evidence. Okay, to finish off, let me put this question on the table. What is confirmation theory? Well, it could be one of two things. It could be, on the one hand, the study of the logic of private scientific reasoning, which is just the logic, I think, of inductive reasoning in all humans. Okay, so not a topic for philosophers of science in particular, but for epistemologists and I suppose cognitive psychologists as well. That's one thing confirmation theory could be. We should probably stop giving it this philosophy of science name, confirmation theory, and just call it inductive logic or something like that. But the other thing it could be, or at least the other activity, enterprise that could unfold under the umbrella of the term confirmation theory is an investigation of the rules of public scientific argument. This is going to be something that is the special responsibility, as I put it here, of philosophers of science. And it's going to consist of teasing out answers to these kinds of questions. First of all, what is the criterion for empirical evidence laid down by the rules of argument? And here I think a formal theory is possible, something that's, I don't think Hempel quite got it right. Actually, in particular, I don't think the yellow banana is, officially speaking, evidence for all ravens are black, even if it does give you a little bit of more reason to believe that hypothesis, as many people have argued. But I think a formal theory here is possible, one that, as I say, would be true for science as a whole and at a level of generality above particular kinds of statistical testing and so on. The other thing that can be investigated is, as it were, the at a sufficiently general level, the procedures for exhibiting evidence and the connections between theory and evidence. I'm not totally sure here that a formal theory is possible. Maybe it would have to be a little bit more informal. But I think again, it's a subject matter. There's an important subject matter there that we can all investigate. Okay, so to conclude, and this is my very last slide, confirmation theory has to divide into two quite different enterprises that are concerned with delineating, in both cases to some extent formally, two really different kinds of structure. Both of them are structures in which evidence and theory are related. One is more about evidential support as we used to think about it, but the other one, this thing about the rules of public scientific argument, is about what counts as evidence for a theory. We need to divide up our inquiries, pursue them separately, and expect rather different looking theories at the end of the process. Okay, and that's it. Thank you very much.
Thanks a lot, Michael, for that really rich talk. I can go ahead and unshare your screen now, unless you want to keep it up.
Yeah, I'm just taking care of that as soon as there we go.
Okay, yeah, so thanks a lot. And I'm sure there are a number of questions. You set us up for a really productive discussion. Before I open the floor to questions, let me just remind you that if you have a question, please use the raise hand function on Zoom to ask your question. If you're unaware of how to do that, you go down to the participant button on the bottom of your Zoom screen. When the participant window opens up, there should be a button on the bottom for raise hand. Please click on that and raise your hand. And I would also request that you keep it to one question at a time. If you have more than one question, please raise your hand again and I'll cycle back to you once you have another question. And let me, just one final thing to mention. For those of you who are maybe attending for the first time or are not aware of this, we have a website where we have videos of past lectures, and pretty soon we'll have a video of this lecture up as well. And you can also on that website sign up for our mailing list and to be informed about future lectures. I've linked the website in the chat, so please bookmark that if you're interested. Okay, let me now go to the questions. Vipul, please go ahead, unmute your mic and ask.
Thank you, Professor Strevens. I'd like you to elaborate a little more on your notion of detail in scientific research, because maybe I've misunderstood your position, but I was wondering if I could take this demarcation that you're drawing between private and public argument, public reasoning. So for instance, if you take qualitative disciplines, anthropology, for instance, the work is actually about detail, very specific context, very specific confirmation of what's going on in a cultural situation. But it's not about suppressing your subjective ideas and notions. In fact, I don't see there is any demarcation between official platforms and private reasoning. There is an encouragement. For instance, if you take the method of autoethnography, the insistence is on bringing your subjective notions to official argumentation. So I was wondering if you could elaborate on what you mean by detail in natural sciences. Thank you.
Sure, thanks. Yeah, I'll say a couple of things. First of all, something I didn't get to emphasize in the talk itself is that the detail can be of many sorts. So it needn't be quantitative detail. It can be a matter of a very complex causal structure, for example. So when we're studying, say, developmental genetics, we're dealing with these very complicated causal sequences. but the detail is not so much in the, as it were, some number many places after the decimal point, as it is with some more traditional examples like relativity theory. It's rather to do with the intricacy of the mechanism. So that's a different kind of detail. Likewise, a description of in ethnography generally of the way that some particular culture or society organizes itself, the attempt to elucidate the norms and the way that people behave within those norms, and sometimes, of course, try to get around them. That again is a kind of detail, and it's a rather elaborate detail, but it's typically not quantitative at all. So I mean this notion of detail to include all of those things. Okay. Now, you asked in particular about autoethnography, and I think you have in mind, I'm thinking, that end of the spectrum of the sciences, which is often called humanistic in some ways.
Yes, yes.
My take on the humanistic end of the sciences is that these are places that have not necessarily, where the full suite of rules of scientific argument have not necessarily been fully enforced for one reason or another, presumably, I mean, including good reasons for sure. So the reason that they're regarded, I think, by their practitioners as much as by anyone as being a little bit different from the vast majority of what most scientists are working on, is precisely that the rules of scientific argument are not adhered to so closely, or people are trying out something a little bit different. I hope that doesn't come across as merely being ad hoc. What I'm pointing to a kind of a recognition on the part of the practitioners themselves, quite explicitly, that the standard rules are loosened a little bit. A completely different example of this, if some of you may be familiar with, is the call currently for a post-empirical physics. So some proponents of string theory in particular are wondering if they might loosen up the rules of scientific argument a little bit so that appeals to things like explanatory elegance can actually be made within official scientific argument, since it's so hard to find any kind of decisive evidence. Yeah. So the fact that these are the rules of scientific argument doesn't make them, as it were, unrevisable. What if I put all this in the form of a empirical theory itself? What it predicts is that those people in the scientific tent who are not conforming to the standard rules will be well aware of that fact and will apologize or argue for or find some other way of recognizing or marking the fact that they are not, as it were, doing it in an entirely standard way. Does that so for the particular case that interests you, does that seem like to capture the mindset, say, of the autoethnographers?
Yeah, but I'm wondering, are you making a stagist sort of argument that at some point anthropology will reach the stage? Is that the argument you're making, or you're saying that it's okay to not make this demarcation in some fields?
I think so. So two things there. One, it's not stagist in the sense that, I mean, look at the case of post-empirical physics is a nice example where you have the direction going the other way. Yeah. For reasons that are certainly worth taking very seriously. So I take it that the official rules of scientific argument have this motivational power, which has been a huge boon to science. It's a very, very good thing. But it doesn't follow from that there aren't other good things as well, and that sometimes we might want to have some of those other good things as well. So I think I certainly don't want to be prescriptive about it. I don't want to say that there's anything wrong with humanistic science. I think of my own work on, if you think of it as as the empirical study of science, nevertheless as not conforming really to the rules of scientific argument in the full sense, so as being a little bit more in the humanistic camp in that very way. In fact, the reason I decided to frame these ideas as a general audience book was in part to escape the discipline, if you like, of academic papers. So I don't want to disparage that kind of research, and I don't want to say that it needs to reform itself in any way.
Okay, you said two things. I was wondering.
Right, one was about whether one was more a normative thing about whether science should be this way. So about whether we should whether the humanistic social sciences should seek to be less humanistic, and the other was more, I may have just read this into your question actually, was about whether in some sense this was an inevitable historical process, so that things are bound to end up that way ultimately.
Okay. Yeah.
Thanks,
no
Vipul.
to both of us.
Yeah. Thanks, Vipul. Prashanta, please go ahead with your question. You're currently muted, Prashanta.
Is okay now? Can you hear me?
Yes, go ahead.
Professor Strevens, thank you. You're definitely successful in making an accessible book. But I'm coming from philosophy of statistics background. So please pardon my question regarding your main part of the talk. Before I come to the main part of the talk, I would like to say that the quantitative part of science is always there. Higgs boson, Newton's reference to simplicity reasoning, and all those things are there. But that's not my main part. So let me get to the main part of your argument. So you have a long idea about this private epistemology and the public epistemology. And actually, we did work, and you refer your papers reconstituting authority, where you talked about that. But this private and public epistemology, you are trying to defend or want to reassess Hempel's argument. But the way we did is to make a distinction between confirmation and evidence, where confirmation is the agent-centric subjectivist, and whereas the evidence is the data provide evidence for one hypothesis against the other relative to the background information, independent of agent's belief. So my point is that you can still able to do the private epistemology and the public epistemology if you make a distinction between confirmation, which is subjective, and evidence, which is objective, and still we have both, and actually that conflation dates back to Hempel's famous paper. So I'll stop here.
Okay, I didn't hear you say anything that I want to disagree with.
That is because
would you be satisfied if I just said that all sounds more or less right to me? Or do you think I'm abandoning something important in my own position?
So you are not making a distinction between confirmation and evidence, which is a very, very pivotal distinction, dates back to Hempel and all the Bayesian epistemologists, most of them, they conflate that. And if you have the conflation, then you can capture the public and the private epistemology.
Yes, well, I guess I see myself as making precisely that distinction without necessarily using those words. So on the confirmation side belongs everything I've associated with private scientific reasoning, whereas the rules of scientific argument are concerned with precisely the delineation of evidence, what counts as evidence, and what may be introduced into scientific argument. So I see us as, I see you and I as having much the same idea, actually, although we may not be using the label, deploying the label confirmation in quite the same place.
No, that is correct, but it is correct. Definitely, I used your idea in the book, but Hempel himself started the very first page, second page. He said, if favorable data is one which confirms the hypothesis, and unfavorable data is one which disconfirms it. So it dates back, this confirmation evidence conflation dates back to Hempel at least.
I entirely agree. So my defense of Hempel is very measured. In fact, it's not a defense at all. I think Hempel did not make the distinction that he needed to make in order to establish, to get away with what he was doing. What we can do, though, is look back and see that in some of his limitations come from a successful transcription, as I put it, of what's going on in the scientific journals, and that's as much as I want to say in terms of endorsing Hempel's view. Everything you've said about Hempel, I in fact quite agree with.
Thank you very much.
Okay, thanks, Prashanta. So Shrita has typed out a question. I'll just read it out. The question is, can you please expand on your opinion on Hempel's confirmation theory and the problem of underdetermination? Underdetermination, as we understand it, brings out the issue that a single piece of evidence or empirical data can support two equally competent theories. Then what burden does the problem of underdetermination bear on a scientific theory, as you seem to focus on Bayesian method, which relies on probability or statistical data? It demands quantification of data. Confirmation theory, on the other hand, does not focus on statistical data, if I'm not wrong to say so.
Well, I suppose the honest answer is I don't have a great deal to say about underdetermination. The proper logic of private scientific reasoning presumably will have quite a bit to say. I see, I'm thinking in response to the previous question, maybe it is a mistake to use the term confirmation at all for the rules of scientific argument. I mean, you see in my presentation, I myself shied away from it. So it's something that's been the reason I'm now rethinking this in front of you in this way is I'm thinking the question here, Srita, is that the question here makes a distinction between what looks like on the one hand a more Bayesian kind of inductive thinking, and on the other hand a kind of inductive logic as captured by confirmation theory. And what I'm suggesting in this talk is a reordering where we put everything concerned with inductive support, whether it's statistical or not statistical, including all issues connected to underdetermination, and in particular the question whether two theories that predict all of the same evidence might nevertheless be discriminated on the grounds, for example, of one being a more elegant or simpler explanation. Put all of those questions on one side, on the private scientific reasoning side. Yes, that's right. On the other side, on the rules of scientific argument side, the side that really doesn't deserve to be associated with the label confirmation anymore, I'm thinking. We have something that really has very little to say about underdetermination. In fact, possibly precisely nothing. So on the one hand, I'm leaving the question of underdetermination to the inductive logicians. And in my own work on the rules of scientific argument, I'm saying we have an evidential support structure which is entirely compatible with massive underdetermination, and also compatible with the idea that other considerations behind the scenes will take care of things, but doesn't in itself do anything to address the problem. I hope that's a satisfying answer, even though of course it's, in one sense, it's completely unsatisfying because it simply moves the problem of underdetermination somewhere other than my subject matter.
Okay, I'm assuming that is satisfactory, unless Shrita wants to chime in. Okay. She says thank you. Okay. Philos, you have a question? Go ahead.
So, sir, thanks for the talk. And My concern is mainly about this official scientific reasoning in presentations and conferences. You said that they do not employ qualitative features of reasoning. Okay, and I agree with the point that when they use qualitative features, that they're talking about evidence, not about the evidential support given to the hypothesis. Okay, but as a Bayesian, that means you as a Bayesian, of course, well aware that then it's likelihood of hypothesis, probability of E given H. Okay, so in a sense, they're talking about the probability of H given E at that point itself when they talk about how likely the evidence are given the hypothesis. Okay, they're in a certain sense talking about how likely my hypothesis to be true. Okay, so my concern here is that in different measures, in different way, in the official communications too, the qualitative features comes up. Qualitative features come to the picture. Okay, but of course, are they explicit? Of course not. Okay, are they explicit as they are talking about the evidence? No, of course not. And also, one another feature is that when, of course, in the presentations we compare the strength of one hypothesis over another. Okay, we choose, suppose if it's against, if you're talking about Einstein, the Eddington presentations, there is a comparison. Okay, there is a scientific presentation, and there is a comparison between two paradigms, two theories. Okay, and how do we compare? Basically, qualitative features is not exactly something which is completely distinct from the. Sorry, quantitative features is not something just completely distinct from the qualitative and comparative. It is in a certain sense a continuation of the qualitative features. Okay, so because qualitative features makes the comparison precise. How can I compare more precise fashion? There the qualitative feature comes, or the degree of support comes. Okay, or how can I compare the different? Suppose there are different aspects to a particular theory, or different aspects of a comparison. How can I bring together all these comparisons together? Okay, there again, this in order to evaluate different levels of comparisons, okay, we need to use a qualitative feature. So in a sense, you're right in saying that it's not explicit, but it's implicit in almost all levels. So how do you respond to that? Thank you.
Let me say a couple of things, which I hope will help. One is that by standing out with Hempel, I got myself into, perhaps unwisely, into a quantitative dichotomy. But that's not really the dichotomy that I want. Because even qualitative confirmation is a matter of inductive support. And when I say this piece of evidence confirms a hypothesis, I'm saying it supports it. What I find in the rules of official scientific argument is something that's not even that. It's not even qualitative inductive support. It's not inductive support at all. As you say, it's the likelihood, say, in the sense that of the probability that the theory ascribes to the evidence, but it's not anything that quantifies the way that the evidence bears on the hypothesis. So I think it will help to abandon the quantitative dichotomy to kind of, as it were, I myself used it when I was thinking about Hempel before I really knew where I was going, and instead look at a contrast between, on the one hand, quantities that are quantifications of support, that is inductive quantities in the private reasoning, and on the other hand, quantities, well, it's not always a matter of quantities, as I was saying to the earlier questioner, it's sometimes a matter of causal detail or just recording the norms of a particular society, but details that are maybe quantitative, but the quantity is never a quantification of support. That's the important contrast. Now, as you quite rightly say, none of what's explicit is going to get the job done on its own. there's a kind of symbiosis here, if you like. It's absolutely critical that scientists who read the scientific literature take what's in the paper itself, the papers themselves, and as it were, infuses it with inductive thinking and starts calculating, in effect, mentally, degrees of inductive support. That's absolutely right, and I don't really think I want to otherwise take issue with the way that you've characterized it. I think you characterized it quite accurately. So these two things are always going on at the same time, but they are, as it were, going on in two rather different venues. One venue is the printed page, a place which is important. This is the venue where the rules of science have to be followed. When you referee a paper, you're ensuring that it, among other things, that it conforms to those rules. That's one venue. And the other venue is the mind of the individual scientist. These two things are always running in tandem, but very different formal structures are governing their operation. But we do need both.
Okay, thank you. Jyoti, you have a question?
Hi. My question is regarding the knowledge produced by different disciplines versus the knowledge produced by science. Like the knowledge that is produced in science, for instance, water boils at 100 degrees Celsius. We know how it is done. It is done by following the science game, the rules of science game, and it's objective in nature. But the knowledge produced by other disciplines, specifically talking about philosophy, the knowledge produced by great thinkers like John Locke, where he says that, since I'm mentioning these philosophers because I'm reading them currently. So John Locke, because there are no innate ideas, or more worrying, somebody like George Berkeley, where he says that there cannot be an unthinking substance outside mind supporting ideas. So there is no way to provide a hard empirical evidence for these substance or a chair. So how do we understand the knowledge produced by these, specifically like by these philosophers? And and in with comparison to science, they are more privileged, less privileged, or whatever their status may be, how are we supposed to understand them, with what certainty? Something would be very helpful if you can say about them. Thanks.
Great, yeah. So philosophy is not science, and philosophical papers are not subject to the rules of scientific argument, of course. But there remains very interesting questions, one of which is, of course, great professional interest to all of us, which is what are the rules of philosophical publication? We'd better have some sense of what that is. But the way I am understanding your question, it's the more theoretical question of, in what ways are the rules of, so I'll, like you all, focus on philosophy, philosophical publication or philosophical argument, similar to or different from the rules of scientific argumentation? Now, clearly we can begin with the question of empirical evidence. It's okay in a philosophy paper to have no empirical evidence whatsoever, or at least this is the usual understanding of philosophy papers that turn, for example, on various intuitive judgments about cases and so on. But you raised the interesting case of philosophers like Locke and Berkeley, who are actually making claims about how the mind works. So that seems to be, whatever you think exactly is the place of the mind in nature, surely the mind is subject to scientific inquiry. And so here are philosophers studying something, generalizing about something that is also the province of scientists. Back in those days where science in the modern sense, the rules of scientific argument, I think, are just emerging from the scientific revolution. And so Locke and Berkeley are still not, there's still these fine traditions of thinking about how the mind works that are not subject to the rules of scientific argument are in full flight. But how are they different? I think that the right answer to that question is a relatively simple one, which is that in philosophy, in the broader sense, I'm not talking about what will happen to your paper if you send it off to the British Journal for the Philosophy of Science, but just philosophical thinking far more generally. In philosophy, I think there are no rules of the same sort as the rules of scientific argument. Okay. Now that doesn't mean that there can't be better or worse philosophical arguments, and that we as the referees of papers are not trying to assess the strength of arguments and making recommendations based on those assessments. But there isn't anything that's analogous to the rules that say you can only argue in one way, namely by using empirical evidence. That is, in philosophy, now of course the empirical evidence part isn't going to translate it over. In philosophy, and I think in the humanities generally, what we find is simply a lack of any such rule. In the humanities, what we find is a tradition that says you can argue for your conclusions in any way whatsoever. Okay, of course, we prefer good arguments to indifferent arguments, let alone bad arguments, but any kind of argument is okay. That would include empirical arguments, and so you find Locke citing some evidence that would count as empirical evidence in a cognitive psychology paper. But it includes all of these, any other technique that we philosophers think is somehow convincing, appealing to intuitive judgments, appealing to theses that somehow just seem to be self-evident, and whatever other things philosophers do. So the characteristic of the humanities is not to have so much to have its own set of rules, but to have to avoid having rules of that sort. I should say, just so that doesn't sound completely nuts, I should say that different areas in the humanities and different subdomains within particular disciplines, subdomains of philosophy, for example, and even different journals within a subdomain, different journals in philosophy will have their own customs. And as professionals hoping to make a career, well, often we know that such and such an argument is likely to play better in this journal than that journal. This journal likes formalization, this other journal not so much, that kind of thing. But if you were to go to write down the overarching rules of philosophical argument, you would find that there are none. So that, I hope that casts some light on your concerns.
It does. This is very, very helpful. Thank you.
Okay, thanks a lot, Jyoti. Don, you have a question?
Yeah, when you were responding to, I think, Philo's, when you were ending your response, you sort of mentioned referee. And my question was about peer review. And I think you mentioned that, look, when refereeing happens, the referee makes sure that, you know, the paper is obeying all the rules of the game. Which sort of, I mean, I was wondering whether, is this what happens when a scientist receives a paper for refereeing, they sort of switch off their private reasoning and go into the public mode of thinking, which seems a little hard to buy. Perhaps that is the case, I mean, if it's an empirical matter. Because, I mean, I was trying to see how it works in philosophy, because we often take into account reviewers' comments and that goes into the paper. And if we are saying that, look, in refereeing, we are just looking at how the game is played, then in science, peer review sort of functions in a very different way. Is that how it works? Thank you.
Thanks. Yeah, that's it's a great question. And the whole subject matter of peer review and how it connects to these rules of the game I'm very glad you raised it. So a peer reviewer in science is among other things making sure that the rules are followed, so that the arguments are conducted using empirical evidence, which means that evidence which means not only ensuring that evidence is that what's mentioned is observable stuff, but making sure that it counts as relevant evidence for the hypothesis, which would mean, for example, more specifically, something like ensuring that we have a statistically significant result. but that's not the only thing a referee is doing. Perhaps the one other very important thing is assessing the importance of a paper. So is this result really interesting? And I think that in assessing importance, it's necessary often to bring in the whole suite of all of the inductive thinking that goes into private scientific reasoning. So it's something that can't be done just by looking at the rules. So if you publish a paper detailing the observation of numerous black ravens in the mountains of New Hampshire, further evidence that all ravens are black, and you can calculate a p-value for that. The null hypothesis is that all ravens are white, and that p-value, et cetera, et cetera. You go through all those motions. That paper is, of course, not going to be accepted, but not because it doesn't follow the rules, but because it's even if this is evidence, it's insufficiently interesting. And why is it insufficiently interesting? Because we already have so much evidence, and because this is adding very little to the case. And adding very little to the case is a matter of, in a certain sense, the kind of sense that, for example, Bayesian cares about, providing very little support, pushing up our level of confidence in the hypothesis by a microscopic amount. So inductive thinking has to go into these kinds of judgments. Not only inductive thinking, also just the overall interest of the hypothesis itself will be something that's being evaluated independently of whether we have evidence for or against it. So to summarize, the peer reviewer is delivering answers to questions, I think, none of which explicitly involve inductive support. Actually, I didn't say that, but I'll say it now. So they're not answering, when a peer reviewer reviews a paper, they're not answering the question, does the evidence that's produced support the hypothesis by a sufficient amount? And of course, it's precisely this fact that they're not answering that question. That's not a part of the referee's job, and typically it's not what they're doing. That's a part of what's created this whole kerfuffle about p-values and so on that we're going through right now. They're not doing that, but they are answering questions that require them to think inductively. So the referee's private reasoning is partly inductive, even if the, as it were, the list of questions they're answering when they submit their report do not include, I think, questions about inductive support as such.
All right, thank you.
Thanks, Don. Darshi, do you have a question?
Yeah, okay. Oops,
You're upside down, Darshi. Yeah.
I'm always upside down. Okay. Okay, Michael, thanks. I'm a part-time philosopher of science and becoming even more part-time. So I don't have anything on the line. So I will continue this question along Jyoti Kishore's line. That is, you didn't go back to Hempel or Lakatos, Loudon, underdetermination, Bayesianism. So basically, we're talking about philosophy of science and philosophers of science, and so when we are making proposing some theses, I call them theses, not theories, because they're kind of meta. They're about what's going on in science, basically, right? So it's kind of an anthropology. And so I wonder, whether, is there scope, just following on Jyoti's question, is there scope for doing empirical research in the sense of looking at, okay, you take one specific domain of physics and you take 1,000 articles, okay? You take 1,000 articles and now you test some of these theses, okay? I did something, as a fun thing in 2015. That was take the realism, anti-realism debate. And through Google Scholar, I tried to track down these terms. Realism, of course, is very old, but when did anti-realism emerge? And in this search, I didn't find any scientists using this term. So So I think we can go to Bayesianism, anything, anything technical that the philosophers of science are doing today. And I want evidence that that this in the scientific articles, are the scientists using these terms, right? And how often? And if they're not, then our reading is theory laden. In this case, thesis laden, of the thesis we want to support. I just want to a very nice thing I saw end of chapter 3 of your book. The rule I have in mind allows partialities and power politics to dominate day-to-day scientific inquiry. I tend to totally agree with this. Okay, it's a good thesis. I think this happened, but how do we quantify? How do we take 1,000 articles in a particular domain and a particular research program and try to verify this? It'll be like very difficult. I think it can be done. So I think some people should be. I mean, I'm not going to do it, but I think some people should be doing this. This is my.
Yeah. No, I mean, the kind of investigation that I'm laying out here, the one that I'm saying Hempel was almost kind of inadvertently doing, and that I'm suggesting we do, is something that can be partly conducted in this way. So actually, when I was writing the book and thinking in particular about the role of beauty in science, I did do something like this. Actually, it was one of my graduate students who was a philosopher of physics and had many friends who are in physics, kindly agreed to engage his friends to look through various bits of the physics literature. Of course, this is, as we say, unsystematic and not very scientific, but we're all philosophers here. And take a look to see if it was really true, as I claimed, that beauty is not advanced as a reason to believe a theory. It's not given as an argument in favor of a theory. And we found that does in fact seem to be correct. That I myself took a look at, I was writing about Murray Gell-Mann, and so I took a look at some of his classic papers, but that was enough empirical work for me. But I suppose my team of physicists were able to cover a lot more ground. Again, not in a very systematic way. As you yourself said, there are so many papers that are published in this area that it would be quite a stupendous undertaking, even in just one area of physics, to really do an empirically responsible survey. But something like this can be done, and I was at least heartened to hear back that I wasn't completely on the wrong track about beauty. Likewise, something we can do is look at the kinds of, and here on the other hand, I only have experiences, but we can look at the kind of language that scientists use, support-like language. One thing that's always struck me is how often scientists use the phrase, the evidence is consistent with the hypothesis, which looks like which, to a philosopher who's looking for a sign of inductive reasoning, sounds like a crazily weak claim. It's consistent with, I mean, almost everything is consistent with the hypothesis, so what? But it's a very neat way of making a claim about how the evidence and the hypothesis are connected without making any claim of support whatsoever. Of course, it's not, more is going on than just the verification of logical consistency, obviously. But nevertheless, it's a striking sign of the refusal, the principled refusal to talk the language of support. So I think we can, in short, yes, I think we can do this project, and I find that the early signs are encouraging. I think that there's good reason to think that what we find in official scientific argument and scientific publication conforms to this kind of Hempelian supportless way of thinking about evidence and theory.
Just to carry on, I mean, I don't understand how something like underdetermination or Bayesianism becomes a null hypothesis. It's more by force, So, somebody comes up with underdetermination, everybody jumps on the bandwagon. I mean, how is it really established as a null hypothesis? So if I want to reject it, of course, I won't do it also. It's like rejecting a null hypothesis with a confidence interval and all. But how does it get established at that? That is, I think, a important point.
You mean, how does null hypothesis testing get established as such a dominant method?
No. How does something like underdetermination within or Bayesianism within the philosophy of science assume the status of a null hypothesis? That's what I'm saying. It's just it just happens at one time, and people just follow it on the bandwagon, and that's it.
Yeah, well, I don't disagree that there's a lot of bandwagon effect going on. I mean, it's not necessarily a bad way to organize inquiry. You know, we can't be thinking about everything at once. So maybe there's some real value to having people all converge on a particular way of thinking. Yeah, I mean, I suppose in a way this was Kuhn's point with his paradigms. Everyone jumps in and really starts pushing some particular idea and seeing if they can solve all of its problems and make it work. And then finally they all get exhausted and wander off and find something new to do. And that way you get the kind of concentration and focus you can have. You avoid the distractions of just having to learn to understand one another because you've been brought up in this one way of thinking. You become a Bayesian, and that's good for 20 years of professional philosophical life. And maybe if that's the only thing you ever think about, you yourself are intellectually narrower as a consequence, but perhaps you're a more valuable member of the community as a result, because the Bayesians get together and they can just start talking at this incredibly high level of sophistication. Or say the Bayes-Natter interventionist causal modelers would be another case of this. And there's no, they understand one another. They can, as Kuhn would say, they can really push the program much further than we would be able to if we were trying to cover all of the ground, cover all of the viable theories at any given time.
Okay, thank you. Nilanjan has typed out a question which I'll read out. He says, if we say that lack of total evidence is a token of irrationality, then practically no reasoning about empirical matters would be rational by definition. It would follow that even private scientific reason would not be rational. At best, considering more evidence would increase rationality a bit. Could you say more about why total evidence matters to rationality towards one's beliefs? I can understand more evidence being relevant, but total evidence would be unavailable. Hence, science would be irrational in a very ordinary but seemingly wrong sense here.
Do you mean maybe, I think maybe it was Carnap who used the term total evidence. So what he meant was you should use the totality of your evidence, but of your evidence. So not the totality of all possible evidence. So everything, all evidence that you can get your hands on, you should get your hands on, as it were. No, maybe that's putting it in a way that's subject to misinterpretation. You should, when deliberating, you should take into account everything that you currently know. So the principle doesn't enjoin you to go out and get more evidence. I mean, maybe there's another principle that does, but not this one. It simply says everything you know and that is relevant should play a role in your deliberation. So I'm not sure if I've correctly understood this question. So if I've correctly understood the sense in which, but it sounds to me like in Nilanjan's question, total evidence is being understood as something stronger than that, a demand that we go out and get more evidence. Am I on the right track here, or completely misunderstanding?
Nilanjan, do you want to respond? We can't hear you. You're unmuted, but I don't think we can hear you. Maybe you could just type out if you think Professor Strevens has interpreted you correctly. Or... Okay, I'm not. Okay, maybe you'll type it out. Let's move on to the next question. We can come back to it. So,
okay, may I follow up with just one comment, just in case it helps while we're on this topic? The idea that you should take into account all of your current evidence, even that has been thought to be too demanding, because especially if we're talking about the scientific world as a whole, that's a vast amount of information, and no one person can kind of, as it were, survey it all, and no one paper can survey it all. So this is why I qualify it by saying, the principle by saying, insofar as, you know, cost-benefit considerations make it feasible. But in the case of beauty in particular, it seems that scientists have the information about beauty. There's no question, it's right there and they can use it at a very small cost, and yet still they're told not to use it. So that very interesting question of the cost-benefit, the very interesting cost-benefit question doesn't really come up, I think, in the beauty case. I'll stop there.
So Nilanjan has responded saying, even if it is epistemic, it would still be difficult to meet that standard. But I think what you just
I see, yes, right.
Yeah.
So that's right. So it is difficult. Of course, the length you should go to meet that standard will depend on the importance of the deliberation. So, you know, when I'm deciding what table to sit at a restaurant, I guess this is a kind of nostalgic example. You know, it doesn't make any sense to stand there for 15 minutes making calculations about the exact merits of different tables and so on, whereas for deciding what action to take in the face of climate change, it really does make sense to take everything I can get my hands on into account. But I think, again, that even if we agree that the principle of total evidence is too strong, nevertheless, there's the thing that it's trying to get at, the standard of rationality that it's trying to get at, is something that's violated by a complete prohibition on considerations of beauty. To say, I have the information about beauty right here, I'm not paying anything for it. I don't have to spend time thinking about it. I'm thinking about it right now. And also, it's very important, provides me with a lot of guidance, and yet I'm going to ignore it. There's something wrong with that.
Okay. So Lilian has typed out a question as well. She says, speaking of reviews, my rather light question stems more from a response from NYT reviewer Jennifer Salai about your book, The Knowledge Machine, than about the talk you've given today. So hopefully they could be tied together. Salai said he may well be right about the exceptional cases of great scientists breaking the mold of inculcation, but from a book about the history of science, I wanted more proof. Then again, The Knowledge Machine is ultimately a work of philosophy and should be considered an ambitious thought experiment. I'd love to hear what you thought when you first read the review, and perhaps talk a bit about the acceptance of the place of philosophy of science to work on the rules of public scientific argument, as you mentioned today, by the scientific community or general public.
Thanks. Yeah, well, it's not that. I guess the first half of that question is lighter in the sense that you're asking for my personal reaction, and the second half is a deep and important question that's not just about me. But I'll start with me. I thought that Jen Salai's comment was somewhat fair. I think she probably didn't really mean thought experiment, but something more along the lines of a speculative theory. And as I admit I've taken advantage of my position as a philosopher and not a sociologist and also the writer of a general audience book rather than a scientific paper to some extent speculate. You know, I hope that I've given some reason for everything I've said in the book, but I certainly haven't given decisive reasoning. What I've said about scientists in particular, I mainly relied there on what other scientists have written and said to me about their impressions of their colleagues. So I'm operating with testimony. Now, on the question of the place of the philosophy of science, well, you know, one of the reasons I wrote the book was to help raise the profile of philosophy of science. You know, I'm sure many of you have run into various disparaging comments that scientists themselves have made about the philosophy of science, and say philosophy of science doesn't help us do what we're doing at all. And in some sense, I think they're right. They should just be left to get on with following the rules of scientific argument, and they shouldn't distract themselves by thinking about why the rules are the way they are. Just like those Bayesians who are more valuable if they think less about just how monomaniacal they're being. So scientists maybe are more valuable if they're not thinking too much about how science works as a whole. But the question of how science works as a whole is a tremendously important question, and we as philosophers of science are in a terrific position to raise that question and write about it for the general public and for anyone who's interested in those kinds of questions. And that's something I'm trying to do here.
Okay, thanks. So I have a question, which I'd like to ask. So it's, I guess it follows on from a lot of other questions that have been asked, but it's about why you reject the kind of way of objectivity objectivity as being the basis for why public scientific argumentation differs from private reasoning. And so here's the immediate thought that struck me when I was listening to you describe the differences, is that what you have in public argument is likelihood. So they're not concerned with confirmation at all in the sense of like the difference between posteriors and priors or likelihood ratios or something. They're just concerned with the bare likelihoods. So it's not so much a question of how much the evidence supports the theory. And so from a at least subjective Bayesian perspective, you can argue that this is the appropriate role for science, that the subjective stuff, which is, so the priors should be subjective to a degree. They might differ from person to person. The priors are what are influenced by considerations of beauty and so on. And what the paper is giving you is the likelihood. So now combined with your priors, you're able to actually get confirmation, right? So, and in a sense, that does seem like the objective versus the subjective, at least from that particular subjective Bayesian perspective. So yeah, I'd like to hear what you think about that.
Thanks. Yeah. So what you just said really quite nicely reflects my thinking originally when I was thinking along these lines. But you know, the likelihoods are pretty objective when we're doing toy examples of Bayesianism, where the hypothesis is that the coin is fair and the evidence is a sequence of heads or something like that. But as soon as we get outside of those examples, to calculate a likelihood, we have to bring in the auxiliary assumptions. And into those calculations of the likelihood are going to figure the priors for the auxiliary assumptions, which are often just as subjective as the priors for the main hypotheses. So the subjectivity does come back in to the calculation of the likelihoods in these more realistic cases.
Couldn't you argue that that's, so here's what seems to happen in at least a lot of empirical work in science, is that in some sense you do, so you have a model and your likelihood is the probability of the evidence given the model, and there's an acknowledgement that the models are not kind of fully capturing the hypothesis, and there's an acknowledgement that, I mean, in some sense, it's true that in producing that model, you're relying on a lot of auxiliary assumptions. But maybe you could argue that, look, that the aim of the scientific paper is just to argue that the probability of the evidence given this model is such and such. And then even the questions of how plausible the model is are kind of outside the domain of the purely objective scientific argumentation. Right?
Great. Yes, what you said is in fact exactly what I do think. So what you typically, when this would be a different way to answer your question. What a Bayesian means by a likelihood is different from likelihoods as calculated in scientific papers. For a Bayesian, a likelihood is the subjective probability of the evidence given the theory, and that's going to hinge on the priors for the auxiliary assumptions. But in a scientific paper, when you calculate a likelihood, what you do is you simply bring in the auxiliary assumptions, assume that they're true, calculate the likelihood, and so what you get is the likelihood contingent on the truth of the auxiliary assumptions, which is an objective thing. So you're, in effect, you are exhibiting a kind of a logical connection between the evidence and the main hypothesis, but really more exactly the logical connection between the evidence and the main hypothesis together with the auxiliary assumptions. That is an objective thing. To that extent, it's right to say that scientific papers are concerned with objectivity and presenting something that reaches a certain standard of objectivity. And in fact, this is in fact something I say in the new book. So you'll see the idea of objectivity does survive there in precisely the guise that you've just very nicely summarized it, Tarun. Yeah, maybe I guess, and I suppose think of the motivation answer as being the response to the Bayesian who says, yeah, but what's the good of that? That's not the likelihood I need to assign a posterior to the hypothesis. And the motivation answer says, here's why. First of all, I'm giving you some information that you need. So of course there's that, it's fulfilling that role. But the reason that we stop there there's this other reason we stop there too. Yeah, let me.
Okay, all right, yeah, thanks. Okay, so unfortunately, we are out of time. Although once more, serendipitously, the questions seem to have run out at exactly the. I'm assuming that it's not actually serendipitous, just people stop asking questions when time is about to run out. I keep saying it's fortunate, but it probably isn't. Anyway, thanks a lot, Professor Strevens, for that wonderful talk and for staying with us for this long discussion, answering all the questions. Really appreciate it. And thank you all who participated for your great questions and the great discussion. And I hope some of you will join us next week when we have Nilanjan Das giving a talk. We'll send out a flyer about that soon. So yes, thank you very much. I really appreciate you doing this early in the morning.
Thanks so much. Thanks for the questions. Of course, feel free to follow up by email.
Okay. All right.
I hope you enjoyed it.
Yeah, it was at least I shouldn't speak for others, but I'm sure everyone enjoyed it. I really enjoyed it. All right, goodbye everyone. See you next week.
All right. Yeah. Okay, bye.